All right, looking at the unit review A for Chapter 3 in Advanced Math. Start with number 5. And the function is f of x equals 4 to the x. So that's pretty much the parent function. And so if I was to graph it, it would go through the point 0, 1. A little bit steeper because the base is 4. It's a little bit bigger. But so if you look at that, that is graph number or letter C. That's graph C. Number 6 is 4 to the negative x. And if you make the x negative, that reflects you over the y-axis. Do you remember? So it's the same one as the one over here to the left, just as it goes up the other, still going through that same point. Right? That's 0, 1, 0, 1. Okay. And that, oh, sorry, that was actually graph D. That was graph D. Number 7. Okay, now this is making the whole entire f of x negative. So when that's the case, that reflects it over the x-axis. Okay. So if the parent function was this one, the graph that we would do is that is actually what it looks like right there. It's this bottom one here underneath because it reflects over the x-axis. That is graph B. And then 8, that's f of x equals 4 to the x plus 1. Okay, so I'm not actually adding it to the x up here. I'm adding it outside of that. So if you kind of look at it like this, it's a vertical translation. So instead of going through the point 0, 1, it's going to go through the point 0, 2. So it's the same function, just a little bit higher. And so you can see that as graph A. Okay. All right, jumping to number 33. And 33 says find the value when x is equal to 16. So the function is f of x equals the log base 6x if x equals 216. So I can sub that in. And I can either walk the dog on this, convert, or formally convert to an exponential. But I'm just kind of asking myself, what can I put on a 6 to make it a 216? And I can rewrite 216 as 6 to the third. It's one of our inverse properties. So the answer is just 3. 34. It's asking me log base 7 when I plug in a 1. So they're basically asking me after I plug in, what does that equal? Well, they're asking, what do I put on a 7 to equal 1? So remember, this value right here is ever a 1. The only number that works for that is 0. Okay, because 7 to the 0 is 1. Um, 35 is after I plug in, I get to the 1/4. And so I'm going to go ahead and actually convert this one to an exponential, but I can do it the same way basically. And so this is 1/4 is equal to 4 to the a. Using that dummy variable to kind of hold the place. And I can rewrite this as 4 to the negative 1. And if the bases are the same, the powers are also the same. 36. Okay. So you got to mess around with the decimals a little bit, but it's basically after, right, for 36, it's log base 10 to the 0.00. Like there's 4 zeros there and then a 1. So if I get a calculator just to kind of experiment a little bit, like if I did like 1 over 100, okay, and I wanted to get a decimal on that, right, that's 0.01. So you see, I got to get to 4 zeros, right? So I'm going to need a couple more, 3 more zeros on that. So I'm going to go to, well, let's see what happens with 10,000. Okay, so 1 divided by 10,000, right? And that seems to work right there. And that is 0.00001. So I can rewrite this value right here, just kind of makes my life a little easier, I think, as 1 over 10,000. Right? So then if I wanted to convert to a logarithm or exponential, I could do that. And basically I'm looking at 10,000 equals 10 to the a, right? And if I do that, this is the same as 10 to the negative 5 equals 10 to the a, and a equals negative 5. Right, moving on to number 51. Number 51 is saying use change of base. So I basically have log base 49. I want to get a decimal approximation on this. I'll use the ln for this first one. All right. And then I would just enter that in my calculator. And I could say the ln of 9 divided by the ln of 4. That comes out to about 1.58. If I round a little bit at the end there. Oops, sorry. Hit the back button on accident there. 53. Same thing. And I'm looking at saying log 14, 364. I'll use base 10s this time. Oops, sorry, that's a 14. And then plug that into my calculator, and I'd say log 364. It's about 2.5, then divide that by the log of 14. And it gives me a decimal of about 2.2345.